I'm going to demonstrate creating plots of predicted probabilities in R. The data I'm going to use comes from the genocide and politicide model dataset. So we're going to look at the relationship between ethnic characteristics of the ruling class and the probability of genocide. So our dependent variable is a binary measure of genocide. It takes on a value of 1 if the country experienced a genocide in a particular year and 0 otherwise. And then our main independent variable is the ethnic characteristics of the ruling elites. So this is a categorical variable. It takes on a value of 1 if the ruling elites are from a non-ethnically salient class. It takes on a value of 2 if the elites are from an ethnically salient but minority class within the population. And then it takes on a value of 3 if the ruling elites come from an ethnically salient majority group within the population of the country. So we're going to examine this first model. We're going to use a logistic model. We're going to call a summary of the model. We can see that ethnic characteristics of the ruling elites does have a statistically significant and positive impact on the log odds of genocide in a country in a particular year. So next I'm going to calculate the probability. So I'm going to take this coefficient and transform it into a probability space. So first I'm going to show you that I'm returning the coefficient on ethnic characteristic. So when you call coef model 1 and then this 2, it's telling it to call the second object. So here it's returning the coefficient on the ethnic characteristic of the ruling elites. So next I am going to calculate the inverse logit of this coefficient. So this gives us the marginal effect of ethnic characteristics on the probability of genocide in a country in a particular year. And so it's about 0.65. So now we're going to create a really basic plot of this marginal effect. And so just to review this code, I've called the plot function, and you can add x labels, y labels, specify the y limit. Here I've told it to not return the axes, so here below I can specify them more particularly. And then this is just a very simple loop. So I am just pulling in the ethnic characteristics. So there's only one object in this loop. I can specify as many as I wanted. For example, if I had 3, this line of code would be 1:3. And now here below, I'm going to produce confidence interval around our estimate. This PCH equals 16 tells R to produce a particular dot on the graph, and the CEX equals 0.5 tells it what the size of this dot should be. So next I'm going to run the code to specify the axes a little bit more particularly. So axis and then parentheses 1 tells it that I'm going to be specifying things about the x-axis. Then here, when it's 2, this is telling it that I am going to be dictating characteristics of the y-axis. And LAS equals 1 tells it to return labels that are horizontally oriented. They could be vertically oriented if you prefer. Then here, we're specifying a label, ethnic rulers, at the position of 1. If I had more than one label, it could be 1 colon and then however many labels you have. So in this case, for the y-axis, I have 8 labels. So I have 8 at equals 1 through 8. And then this box tells it to produce a box outline around the figure. Now I'm going to run the axis code. You can see this is not a very beautiful graph, but it reports probability of genocide. You can see that the confidence interval doesn't overlap 0, which tells us that the effect is statistically significant, which is what we also saw when we reported our logit model. But here we're reporting the probabilities. So next, I'm going to add regime type to the model, particularly a binary measure of autocracy, which takes on a value of 1 if the country is autocratic, and 0 if the country's regime is not autocratic. So autocracy also has a statistically significant positive impact on the log odds of genocide in a country in a particular year. Here I've calculated the inverse logit of each of coefficients above. So we can see that the marginal effect of autocracy is substantively larger than it is for ethnic characteristics of the ruling elites. So now I'm going to plot my intercept on my first x variable, the ethnic characteristics of the ruling elites, as well as autocracy. So I've changed this to be 1 colon 3 for my 3 objects, and we're going to calculate their inverse logit. So we're going to report the probabilities again. And here's each of their marginal effects. And again, the confidence intervals don't overlap 0, which indicates that they have a statistically significant effect on the probability of genocide. And also it seems that autocracy has a higher substantive impact on the probability of genocide than this ethnic ruler variable. So next what I'm going to do is I'm going to set specific values of autocracy and the ethnic ruling class variable. And what I'm going to do is run through these 3 different types of the ethnic ruling class characteristics, all within non-autocracies first, and then within autocracies. So we can see how the effects of the ethnic ruling class vary with respect to probability of genocide, depending on whether the country is autocratic or not. So I'm doing this by first calculating the prediction based on these different values. So first, when the ethnic ruling class is set equal to 1, meaning that the ruling class is not ethnically salient. And then again, setting autocracy equal to 0. So this is for a non-autocratic regime. And so I'm going to walk through this so we can see these different effects. So in particular, just to note what my coef1 is calling, you can see that first it's calling the coefficient on intersect, and I specify 2. It's pulling out the second object, or the coefficient on ethnic characteristic, and then when I specify 3, it's pulling out the third object, which is the coefficient on autocracy. So it's very important that you know what specific variables you're calling, so it's sometimes good just to review this. So when I calculate my inverse logit for my prediction, based on having ethnic characteristic being equal to 1 and autocracy being equal to 0, the probability of genocide under those conditions is about 4%. So next I'm going to set my ethnic ruling class variable equal to 2. And this tells us that the ruling class is from an ethnically salient group within the country, but it is a minority group within the population of the country. And again, this is in a non-autocratic regime. So when the ruling class is from an ethnically salient but minority population in a non-autocratic regime, the probability of genocide is slightly higher than when the ruling class is from a non-salient ethnic group. So next we're going to set ethnic ruling class equal to 3. And 3 means that the ruling class is from an ethnically salient and majority ethnic group within the population of the country. And so we can see that in non-autocratic regimes, when the ruling class is from an ethnically salient majority group, the probability of genocide is higher than in non-autocratic regimes when the group is either not ethnically salient, or when the group is from a non-majority ethnic population. So the probability in this case is about almost 10%. So here I'm going to create a vector with the predictions from each of these models, and then I am going to calculate probability. So again, this is just reporting the probability of each that we've seen above, but it's storing it inside one vector, so I can run my code below. So here you can see I've replaced what I called above my intersect with diff. So everywhere that was, I've replaced that with diff, right, because this is now the vector creating pulling the different coefficients. I'm going to take the inverse logit. So this plot will show the predicted probabilities. These first two lines tell R to, it's priming R to create a side-by-side graph. So I want to display one figure for non-autocratic regimes, and next to another figure showing the differences across this range of the ethnic ruling class for autocratic regimes. And so it's specifying it here. So this is telling it to have one row and 2 columns. You could have 2 rows, 2 columns, several different varieties of combinations. I like to have things side by side, so that's how I'm specifying this. And it's produced our first graph. Now I'm going to run the different predictions for autocratic regimes. So again, first we're going to set ethnic ruling class equal to 1. And in this case, the predicted probability of genocide is about 15%. So when the ruling class is from a non-ethnically salient group, but the regime is autocratic, you see that there's a higher predicted probability of genocide than when the ruling class is from a non-salient group in a non-autocratic regime. And this makes sense because we saw that autocracy had a positive effect on the log odds of genocide in a country. So next we're going to set ruling class equal to 2. So when the ruling class is from a minority but salient ethnic group, the probability of genocide increases in autocratic regimes over when the ruling class is from a non-salient ethnic group. Next we're going to set ethnic ruling class equal to 3. And the probability of genocide is almost 30% at this point. So within autocracies, having the ruling class come from an ethnically salient but majority group increases the probability of genocide over the case when the group is ethnically salient but of a minority status. So theoretically, this is what we may expect. So again, I'm going to create my vector differences. And now I'm going to generate my second file. So I've added this par parentheses op, and it's going to tell it to return the figure in the manner that I like. So here it's side by side. And so we can see, in general, in autocratic countries, as we would expect, there's a higher probability of genocide pretty much overall. But particularly in this case, when the ruling party is from an ethnic majority. So that's how you create some predicted probability figures in R.